morning, everybody. Welcome back to science, or at least as back to science as we can be right now. I'd rather be in the classroom with you, and I hope you're doing okay. Today, I just want to show you the weird headgear I have to wear to record this stuff and kind of block out some noise, and move on with the idea of energy, but starting off with the idea of pressure. So, if you could pause this video and go upload the intro video I had linked to this assignment, it will look a little bit like this one. All right, new science topic right here. Go ahead and click that, and then come back to this video. All right, we'll see you in a few seconds. Okay, so hopefully you checked that out. And what I was doing is I was using a knife to actually deliver some energy to those balloons. Now, we did talk about energy before. We talked about kinetic and potential. What we didn't talk about is the idea of mechanical energy, energy transitions or transformations, and then I would like to get to a lab after we talk about these two subjects right here. But let's start off with the definition of energy. So I need you to take a few notes, real quick ones. All right, the first is a definition of energy. Energy is the ability an object has to do work on other objects, or the ability an object has to do work on matter in general, whether it's changing the behavior of the matter or changing something about the matter. Like, say, we take an ice cube. We add heat energy to the ice cube. What did we do? We ended up changing its phase, and it turns into liquid water. All right, that's all done using energy. All right, now let's take a quick look at this video where energy is going to be delivered to the guy's face using this ball right here. Now the playback's going to seem a bit odd because as they talk, there's it's a little out of sync with the audio, but you can still get the idea. All right, he's about to toss the ball. Ooh, man, right in the guy's face.
Yeah, look at that.
So here we go. His face has a shape. The ball comes in, boom, changes the shape and behavior of his face. Man, leaving his nose behind and everything. All right, so the ball does work on his head. The ball had energy by our definition. And here we go. You can
Oh,
start
it's a
to see
clean
that
it on the
nose.
side of the face. Oh, the shockwaves. Oh, your nose bone moved under your nose. Oh.
My eyes like, what's happened here?
Oh, now the shockwave, your mouth like hung behind.
Oh, man.
All right, that's good stuff right there. There are so many videos you could check out that are all about energy and doing work on people's, I don't know, faces or anything. So, energy, the ability an object has to do work on other objects. And again, we're going to have to talk about the concept of work in physics too. But first, let's start with the forms of energy you already know. Again, take this down real quick. But I had a Nerf bow and arrow in the classroom that I used a couple times. And you remember when I put the arrow on that Nerf bow and pull it back, I'm actually putting energy from myself into the bow. We call that stored energy, potential energy. All right? And anytime you see potential energy from this point on, like if we're trying to refer to it in a short sense, it's going to be just referred to as P, E. Having a hard time drawing. So, potential energy, or PE, is stored energy. Got it? Just like this girl from America's Got Talent way back in the day. I mean, she's got some serious talent. You got a handstand, and she's drawing back a bow. Well, she is putting some of her energy into that bow. The energy is waiting to be used. That is stored energy, potential energy. When she lets go, just like when I let go of the Nerf arrow and it goes flying into the wall or flying into the window, that's a different form of energy. It's no longer stored, it's being used. So one of the ways energy can be used is to move things. We call that energy of motion kinetic energy, just like the arrow moving. All objects, or all moving objects, have kinetic energy. The faster they move, the more energy they have. Whenever we see kinetic energy, we're going to go ahead and refer to it as KE. All right, so potential energy PE, kinetic energy KE, and there we go. That's our when we think about an object in motion or an object that has some stored energy, anytime the energy is tied to a physical thing, to a physical object, we give that energy a different kind of name. All right, we're going to end up calling it mechanical energy. Mechanical energy fits the category of energy, and it's not just one thing, it's actually a combination of things. So mechanical energy is energy that can be used to do work, kind of like our original definition of energy. But mechanical energy is not just one kind. It's not just potential, it's not just kinetic. It's actually the sum of the two types of energy. So you could think of it as mechanical energy. Let's see if I can write this, which we'll call ME. So whenever you think mechanical energy, think ME. It's a lot easier to write on my board than it is to write on this computer. Mechanical energy is going to be equal to all the potential energy there is in an object plus all its kinetic energy. Let's finish that off. Alright, so mechanical energy is the sum of potential and kinetic energy. And there's any kind of example. Actually, there's probably hundreds of examples around you right now, definitely examples outside. But if I were to take one with like maybe a person with a hammer, right now, all the energy in the situation is probably stored inside the kid. As soon as the kid picks up the hammer, he moved the hammer, didn't he? Moving, that's kinetic energy. Then he's got the hammer in the air. That's potential energy. So we're changing the situation around just a little bit right now. So the hammer's in motion. You can tell by these motion lines. So there's some, there's going to be some kinetic energy there. Alright, but it's also above the ground, so there's potential energy. If I add those two things together, guess what I get? Yeah, that's right. I get mechanical energy when I add these two. So he's got some mechanical energy that he put inside that hammer right now. Now what's going to happen if he brings that hammer down on top of the nail? Is he going to lose all that mechanical energy? Is it just going to disappear? No, it's not going to disappear. He's going to use the hammer to apply that energy to do work on something else. In this case, the nail right here. So he brings it all down, and there's still going to be mechanical energy, but he's sent that energy into something different. So he passed off his energy, and now the energy is in the block and that nail. Probably a form of mechanical energy again. What kind? We'll have to see. But the idea is he had energy. He gave the energy to the hammer. Then the hammer gave the energy to the nail. Is the energy really disappearing? No, energy can't disappear. What's happening is he's transferring the energy from one object to another. So when energy transforms from one type of energy to another, it's conserved. That basically means the boy picks up the hammer. That doesn't mean the hammer created this energy. The boy hits the nail with the hammer. That doesn't mean the hammer has lost the energy or the energy's disappeared. It's actually conserved. All that energy is still there. It's now just trapped in something else. So energy can't be created or destroyed. Instead, it will just change form. So please write that down. So when energy transforms from one type to another, it is conserved. The total amount of energy will stay the same. Alright, but now it's going to be a different kind of energy. And it's going to be stored someplace differently. This right here, energy cannot be created or destroyed. That is the law of conservation of energy. And that it's true everywhere in the universe. It's true in stars. It's true in your cells. It's true on the biggest and smallest scales. You just don't get rid of energy. It's always there. Now there's a lot of cases where you can actually transfer energy around. There's simple toys you could use to transfer energy around, like this one. Alright, an old wind-up airplane. So we're going to start off with mechanical energy in the form of potential energy. He's going to actually turn this propeller, which spins the rubber band up, twisting it, and that rubber band, it doesn't want to stay twisted, it wants to untwist. But as long as he's holding on, all that energy has no place to go. As soon as he lets go, the mechanical potential energy is going to turn into mechanical kinetic energy. Alright, all the energy he put in, that becomes kinetic energy, and the plane starts to move as the propeller spins. Again, it's an energy transformation. The energy is not made, it's just transferred first from the kid to the propeller to the rubber band. Then we let go of the propeller, the rubber band unwinds, spins, and that plane moves. And again, energy of motion, that's kinetic energy. Now, we are going to, in our lab, pay more close attention and even take measurements of this energy transformation. And to do it, we have to talk about not just, energy of a spin propeller. We have to talk specifically about where that energy might come from, or the force that might cause the energy to be there. To do that, we're going to think about our old friend gravity. Okay? So start off by drawing this picture real quick, please. If you have to pause this at any point, go ahead and pause so you can draw. I have a red ball up here. It is stored above the ground. That's my straight line right here. Up in the air at this height, it had, now you already know the ball wants to fall. Gravity wants to pull that ball down. But imagine if you lift that ball up, you're going to be doing work against the force of gravity. Your work is the energy you're storing inside the ball. Eventually, the ball is going to fall. The higher in the air you have that ball, the more energy it's going to have. Now, at this point, if we were in the classroom, I'd have that big shot ball. I'd have it held above my head, and I'd let it go. We all know what it would sound like when it hits the ground. It would be loud. Several of you who weren't paying attention would be jumping right now. Unfortunately, I can't just do that here. Maybe I can simulate it. That right there would have been the ball hitting the ground. Now imagine if I started with that shot really, really, really close to the ground, maybe right about here, and I let it go. Instead of that noise you just heard, you'd hear less noise because there's less energy trapped in the ball. If I were to raise it up further, maybe right here, and then drop it, be like that. And if I raise it all the way up to let it fall, because the higher the object is above the ground, the more potential energy it has due to the pull of gravity, the higher it is, when I let it go, the more sound it's going to make when it reaches the ground. Right? I think that makes sense. So once the ball falls, is that potential energy anymore? No, it is not. It is now kinetic energy. As the ball drops from this position straight down, it gets closer to the ground, so its potential energy decreases. But as it falls, it also is moving faster, so its kinetic energy increases. Remember, potential energy, PE, it's all about energy being stored, waiting to be used. And kinetic energy is when that energy is being used to make something move. So as the ball moves faster and faster, it gains kinetic energy, but it loses potential energy. The potential energy of the red ball is converted into kinetic energy. And there's an energy transformation right there. And before you know it, we're actually done for right now. That's as far as I wanted to go. The next thing we'll do is we'll put a few equations to these types of energy. An equation for potential energy, an equation for kinetic energy, and we'll move straight into the lab that I want you to do. Again, I'm still trying to figure out how to do that based on the materials you have or the programs you have available to you. But that's how we're going to move forward until I can finally see you in class again. I really look forward to that. Please check out and do the homework of the textbook assignment I will assign that goes with this bit of notes, and I'll upload more on Friday. Have yourself a good day.